What is a stranded wire conductor? The flexible lifeline, understanding stranded wire conductors. In the realm of electrical wiring, the choice of conductor material and construction is paramount for ensuring efficient and reliable power transmission. While solid wires, composed of a single, continuous piece of metal, serve their purpose in fixed installations, a more versatile solution exists for applications demanding movement and resilience, the stranded wire conductor. Unlike its rigid counterpart, a stranded wire conductor is ingeniously crafted from numerous thin wires, known as strands, meticulously bundled and twisted together. This seemingly simple alteration in construction yields significant advantages, particularly in terms of flexibility and durability. The fundamental composition of a stranded conductor involves a multitude of small-gauge wires, typically fashioned from highly conductive materials like copper or aluminum. These individual strands are carefully arranged and helically twisted around a central strand or core. This twisting pattern ensures that the strands remain in close contact, facilitating the smooth flow of electrical current across the entire conductor. The number and diameter of these individual strands determine the overall gauge, thickness, and flexibility of the resulting wire. A higher number of finer strands translates to greater pliability, allowing the conductor to bend and flex with ease. This inherent flexibility is a key advantage of stranded wires, making them indispensable in applications where conductors are subjected to frequent movement or bending. Imagine the repeated flexing of a power cord for an appliance or the constant motion within robotic arms. A solid wire under such stress would quickly succumb to fatigue and fracture. However, the individual strands within a stranded conductor can slide and move relative to each other when the wire is bent. This distribution of stress across multiple thin wires, rather than concentrating it on a single solid core, dramatically reduces the risk of breakage and enhances the conductor's overall durability. Beyond flexibility, the multi-stranded construction also contributes to a larger overall surface area compared to a solid wire of the same cross-sectional area. This increased surface area can offer benefits in specific scenarios. For instance, it can aid in more efficient heat dissipation, preventing the conductor from overheating under load. Furthermore, in high-frequency AC applications, the skin effect, where current tends to flow more along the surface of a conductor, is mitigated to some extent by the increased surface area of a stranded wire. Given these advantageous properties, stranded conductors find widespread use in a diverse range of applications. They are the backbone of flexible power cables that supply electricity to appliances and machinery. Their resilience to vibration and movement makes them ideal for automotive wiring and the intricate connections within moving equipment and robotic systems. Even everyday items like speaker wires and extension cords rely on the flexibility and durability of stranded conductors for reliable performance. In essence, the stranded wire conductor stands as a testament to how a thoughtful design, employing multiple slender components, can overcome the limitations of a single, solid structure, providing a flexible and enduring pathway for electrical energy.